Good evening, everyone, and good afternoon, depending on where you are. My name is Marcin Kruszyński. I'm the leader of Wire Foundation. Today, I have a pleasure to host a talk by McKinsey and Company. McKinsey and Company is the sponsor of our text mining hackathon and also the gold sponsor of Wire conference. Today, we have two presentations. But before we start, I would like to say a few words about McKinsey Analytics. They combine advanced data analytics solutions with a high in-depth industry and business knowledge. McKinsey data scientists and architects complement strategy and operational consulting and provide clients with advanced and robust data-driven solutions. Our first speaker will be Thomas Mackin, and let me introduce his fascinating biography. Thomas is a partner at McKinsey's London office. He leads consumer tech and media practice in Europe and is the CEO of Quantum Black, McKinsey Center of Excellence and Innovation for AI and Machine Learning. He serves clients on a range of commercial and customer analytics topics and helps them build new analytical driven businesses. Tom spent 2 years outside McKinsey as COO of a privately owned European media company and studied history at the university in the UK. It is my pleasure to have you, Thomas, tonight, and please start your presentation now.
Super. Thank you, Marcin, and hello, everyone. I'm really excited and honored to be talking to you today. And to be the warm-up act for a couple of my colleagues who'll be sort of much more exciting than I am. I wanted to spend the next 15 minutes giving you a little bit of an introduction to McKinsey Analytics and what we do, how we work, and the kind of impact we have with our clients. As Marcin said, my name's Tom, and I hope to give you a little bit of a flavor of this question: why McKinsey Analytics, and in particular. I can get the screen control, there we go. And in particular, how we use technology, data, and some of the capabilities we have around the world to serve our clients. So look, let me start with, what do we think makes us different? Why are we excited about being part of McKinsey Analytics? Well, look, there are sort of 7 things. I'm going to go into in some of them, the ones in white, in a little bit more detail. So firstly, as Marcin said, we work with clients at the intersection of analytics, industry, and functional expertise. And for us, that's kind of part of our secret sauce, coupling some of the sort of deep analytics domain knowledge with people like Yetu and Tomasz at the intersection and with some of our traditional strategy colleagues who are really deep in particular sectors and functions. Second, we focus on change. And ultimately, we create change with our clients. You don't get impact without changing ways of working, people's behaviors, mindsets. So that's the second thing. The third is we are excited to work with some of the world's best technical talent. And we have a kind of broad range of colleagues, whether it's design, data science, data engineering, or even kind of technology architecture, who help implement some of the complicated analytics models we build in our clients' systems as they scale. We focus on building capabilities. We pull all of these different things together in an integrated approach, but also we don't do it on our own. We work with an ever-expanding ecosystem of technology and data partners. And we also try and lead debates in the broader world on topics like ethical AI and the use of data. So, look, all of these 7 things are what makes us excited to come to work each day and work with our clients. Ultimately, though, we are value obsessed. We have a 2-part mission as McKinsey. One is to create sustainable impact with our clients, and the second is to create an extraordinary environment for exceptional people. And I hope that comes across in some of what I'll say in the next few pages. I wanted to start by bringing this to life. So McKinsey's about 100 years old. Obviously, we've changed an awful lot in that time. And over the last 10 years in particular, we've started really pushing the envelope on analytics with our clients. I mentioned up front, one of the things that we think makes us special, and our secret sauce, if you will, is the combination of analytics with industries and functions. And that means we work in almost every sector and every function around the world, whether that's automotive assembly, as you'll see on the top left hand, working on problems like how do we get manufacturing right first time? In the middle, on topics around healthcare, how do we use analytics to help predict the accuracy of surgery outcomes and help improve techniques? And then high tech, which is a sector that I spend quite a lot of my time in, as Marcin mentioned, improving the quality and productivity of software engineering teams, looking at data, hundreds of different variables that determines the performance of those teams and optimizing them over time. So, the first thing is we sit at that intersection. Now, I said earlier, we focus on impact. Ultimately, that's why we get up in the morning. And let me bring that to life a little bit with 3 examples from different corners of the world and from different bubbles on the slide that I previously spoke to. There are 3 different stories. The first is really around capability building. So, for a couple of years between 2017 and 2019, we worked with a large multinational retail conglomerate who have a combination of retail outlets, online e-commerce platforms, and a very complicated distribution center. One of the challenges that they were facing was they knew analytics was core to their business, whether that was personalizing recommendations on the e-commerce platform, or thinking about how do we use data in order to make smarter supply chain management decisions. Over the course of a couple of years, in addition to using analytics and data to help improve business performance, we also trained a vast number of employees, 30,000, taking them through what we call our Analytics Academy, where we take in the line business people and give them skills to lead analytics teams. It was super fun for us because it brings together some of the data and technical aspects of our job together with kind of coaching and large-scale change management. In the middle, we do quite a lot of our work in the social and the public health sector. And over the last 18 months or so, have spent an awful lot of time working with victims of human trafficking, using analytics at the center of a consortium of different public and private sector bodies and well-known NGOs to help understand what are the features when you're rehabilitating a survivor of this most brutal crime. What are the main drivers of successful rehabilitation? And how do we make sure that we improve them as they help reintegrate either back in their home countries or in their new countries? Third, at a completely different end of the spectrum, and this is really where some of the technology that Yetu and others will talk to us about in a little bit. For the last 12 months, we've been working with a well-known copper mining giant to build technology, build a series of advanced analytics models to help improve the efficiency of metal production, metal smelting in particular. Building models to help drive an uplift in productivity, so 15 to 20%, which is then translated into very significant cost savings because we are extending the lifetime of copper mining or copper smelting plants, and thereby also reducing that company's environmental footprint as well. So 3 examples from a multitude of work across industries and geographies that I hope sort of brings to life what impact means for us and how we think about it. Now, look, yes, we're focused on clients, but we would be nothing without our amazing network of colleagues. As I said, 2 of whom I'm joined by today. We're a relatively large organization, 30,000 people around the world, I'll talk about a portion of those who focus on analytics and other technical areas. But the people that we hire are truly special, and I hope that some of you kind of listening into this will have your interest piqued and reach out to us and potentially join us in the firm. In 2018, for example, we got 800,000 applications for about 8,000 roles. Our mix is shifting as well. Increasingly we work with colleagues who spend time in industry and who have some deep expertise. Our alumni go on to do cool things. There are 20 unicorns around the world that are founded by McKinsey alums, our alums continue to kind of lead some of the most interesting and impactful organizations around the world. You may have seen Jane Fraser, the new Citi CEO, was a business analyst and then partner in our New York office, for example. Now, I said I'd talk a little bit about it. So amongst our overall 30,000 colleagues, we have a ton of technical analytics and digital talent all around the world. In fact, 5,000. So roughly 1/6 of our colleague base have a deep technical background. Now, I said these are spread in every continent, and we've got a particular anchor or base in Central Europe, and indeed sort of 50+ colleagues in and around Central European countries, which is a really exciting growth area for us. We also have colleagues in places ranging from Australia, where they work with some of our kind of mining and travel clients, right through to Canada on the West Coast, near Silicon Valley and some of the tech hubs. Now, these colleagues work, and this is what this is part of how we deliver impact for our clients. These colleagues work not in isolation, but in multi-disciplinary teams. And this is, as I said, this is kind of core to how we have impact. Particularly on analytics work, we bring together colleagues that have deep analytics expertise, say, data scientists or machine learning engineers, together with colleagues who we describe as translators, who can help bridge the interface between analytics and business problems. Together with deep experts, are deep technical experts, people like data architects. You'll see Stephen's face at the bottom of the screen there. Stephen's a colleague in our London office at QB, which I'll come on to in a second. Coupled with some of our traditional strategy consulting colleagues, as you'll see on the left-hand side, that bring that deep industry and functional expertise. Now, I just referred to something called QB, and as Martin said in the introduction, I'm part of the team at QB, as is Yetu. 5 years ago, McKinsey bought a small startup called Quantum Black, with a history in Formula One racing, where analytics is used to improve car performance. And QB, we'll hear more about later, is in the last 5 years has grown into the center of excellence within broader McKinsey for AI and ML. It's the place where a lot of our research and development for cutting edge technical tools that Yetu will describe with Kedro sits. And it works hand in glove with other parts of McKinsey, particularly McKinsey Analytics, but also some of our functional and industry expertise. Now, QB, if you will, I'm sure many of you will have seen or had discussions on something like this. QB, if you will, is the kind of center of a network of other capabilities that we bring together for clients. It's the code at the center of a range of other things, all of which combine to help us have an impact with clients, whether that's data collection, feature extraction, pipeline wrangling, as Yetu and others will talk. Now, I'm not going to spoil the party for some of the presentations that will come in a second, but I referenced this earlier. QB in particular has started building out technology to support our practitioners. So not only are we working with clients to deliver engagements and impact on the front line, but increasingly, and where we can't partner, we're building our own tech. That tech is there to help our colleagues go faster with lower risk in a more effective and repeatable way. And you'll hear a little bit more about it shortly. These are things like Platform McKinsey, which is the cloud infrastructure we use so that we can stand up analytics teams really quickly, or causal nets, which allow us to avoid having to repeat code development time and time again as we go into new engagements. But of course, and I suspect this is the background of some of you joining us today on YouTube, we don't do all this on our own. And increasingly we work with a range of exciting data, tech, and analytics companies to help our clients. Whether those are cloud infrastructure providers like AWS, GCP, or Microsoft Azure, or indeed research partners, companies like Element AI, an R&D lab based out of Montreal, that helps push our own thinking on AI and ML and bring the latest research from academia and help our clients commercialize it. The final thing I want to say is one of the reasons that we're all excited about being part of the McKinsey Analytics family is that, yes, while we work with our clients, we also engage with the broader world. We focus a lot on trying to push the boundary on big public debates and share some of our thoughts, our lessons with the wider world. We do this through our own internal think tank, McKinsey Global Institute, which produces a ton of really interesting research on macroeconomic trends and other geopolitical, social, and technology developments, but also increasingly engaging with media and the broader public, for example, through events like this, which we continue to be excited about sponsoring and being a part of. We also engage in debates with others who are thinking and driving the thinking in this space. For the last couple of years, we've been working at the center of a consortium of leading research institutes and universities on a 100-year study for how we think AI is going to develop and change the world in which we live and the industries within which we operate. And some of our colleagues, including those joining us today, regularly take part in some of the most exciting kind of conferences, engaging on the public stage on some of these most important debates. So look, I appreciate that's a whistle-stop tour, and time is tight. And as I said, I am but the warm-up act. But I did just leave you with a few kind of reflections or messages. One is McKinsey Analytics, and QB as part of that, is on an astonishing and really exciting kind of growth curve. We spend kind of all our waking hours thinking about how we can have greater impact at clients, and increasingly we're working across a wider range of industries and functions than we ever have before. And today we've got 5,000 technical digital analytics colleagues all around the firm, including in Central Europe. And we really do hope that what you hear over the next 30-40 minutes potentially piques your interest and means that you would be excited about finding out more. Anyway, with that, I'm going to hand back to my colleagues and thank everyone for listening.
Okay, thank you, Thomas. That was really inspiring talk. Let me go to the second presentation now. So our next speakers are Yetunde Dada and Tomasz Kaczmarczyk. A few words before we start. So Yetunde is a principal product manager at Quantum Black and can speak more about Kedro, which is one of the products that she built for data engineers and data scientists. This is a Python library that makes it easy to build production-ready data pipelines. Yetunde's previous experience includes experience as a data product manager at Barclays, deploying customer journey analytics dashboards with a team of data scientists as well. Her education is an MBA from the University of Oxford. And the second speaker, Tomasz Kaczmarczyk, is a data science specialist at McKinsey Company. Previously, he worked at different consultancies in Poland and abroad. In total, he has 8 years of data science experience. And yeah, let us hear about an introduction to Kedro.
I think I find it so ironic that I've come to the YR conference, one of the world's largest conferences, and I'm speaking about a Python library. But I really do hope that you enjoy this presentation today, and I'll let you in on a side thought. R is still my favorite programming language, but please do not tell my product team this. They might reject me as their product manager. I hope you're having a good evening. As mentioned, my name is Yetunde Dada, and I'm a product manager on McKinsey and Quantum Black's first open source product called Kedro. I'm really excited to talk to you about this because when I used to code professionally, I could have been a user of Kedro. So I'll thread this journey throughout this presentation, and I'll be talking through some of the challenges around productionizing data science code and why you should care about it. So next. So I think the first place that we start is this whole understanding of like, what is your end goal when you're making analytics projects? So you get business requirements from someone and they say to you, okay, we need to do some sort of amazing study. Maybe you've received HR data for whatever reason, and they tell you that the output of your work is going to be maybe an insights report. So you say, great, okay, so I produce this amazing report, we do this presentation, there's some initial insights, and then everyone is excited and benefits from that. But then sometimes they say to you, okay, could we have this running in production? Or could I get a monthly email, which will have details about what was discussed in this report? Or can I have a dashboard? And this is where we actually talk about you perhaps having to think about a machine learning product instead, which is actually code that functions and runs and can be deployed easily. The methods that you use for building this building are quite different opposed to the methods that you'd use for building a larger structure that needs more requirements. So with this, I'll actually move over to the next slide. So a lot of it actually stems when we talk about the challenges of producing machine learning code. We actually start with breaking it down into two places where we typically stumble. And the first one is the Jupyter Notebook workflow. It is an amazing tool for exploring data and for reporting and even for producing, I think, kind of like prototype data science, whatever that looks like. But as soon as you start to actually get into producing more complex workflows, then things start to get a bit complicated. So we start to talk about maybe two impacts that you might see while trying to work through Jupyter Notebooks. The first one might be reproducibility. So in 2019, NYU did a study on 860,000 notebooks found into about 264,000 GitHub repositories. When they tried to run those notebooks, 24% of them completed without error, but only 4% of them produced the same result that was at the end of the cell in the notebook. So we start to see there were many different, maybe there was cache state in the results. Maybe they didn't have the same Python or maybe libraries that were used to create the code, but something was happening there. And then when we start to see what happens when multiple people try to work on notebooks together, we start to find that it's challenging to divide work amongst yourselves because you kind of like have to wait until someone's done with a Jupyter Notebook, then you yourself can go do your thing on the notebook. It's hard to do code reviews, which are necessary for improved code quality. Version control is also an interesting challenge. You can use some libraries, but you always have to extend the capabilities of Jupyter Notebooks to do that. And then, of course, because you're still experimenting, when you have like many Jupyter Notebooks, because you're trying many different things in the Jupyter Notebooks, it gets a bit disorganized. And then we say that it's hard to obviously write more robust code because writing unit tests or even using tools that can scan your code for errors makes it a bit more hard. And then we also find that you've hard-coded variables for perhaps where you've loaded data from a table or saved a data in a table in the Jupyter Notebook as well. So if you ever had to change those values because maybe you're not coding in a specific environment anymore, or it has to be swapped to a friend, you have to find those values and remove them yourself. So let's say maybe you've actually moved on from the Jupyter Notebook workflow and you're now trying to write things in just plain script. So it could be Python script or just plain R script that you're now using because it's a better workflow. So what you find over here is a different set of challenges. Everyone works in different ways. So whenever you encounter a new code base, you have to spend time listening to the person to try and have an understanding of what exactly is in this code base so that you can get acquainted with it. And then you also find that many other tools have to be kind of like cobbled together to make an assembly of what would be this production standard code. And eventually what you find is you end up building your own framework, whatever that looks like, or own set of standards for how everyone should work in this space. And there's so many things that you have to consider. There's an amazing writer who speaks about the challenges of data science today. And he speaks about the growing learning curve that is associated with things that you need to know to produce production standard code for these machine learning products. And the list just gets longer every single day. We always make some jokes about data pipelines. That is just pieces of script that are cobbled together, and you just kind of hope that everything works. If something breaks, well, you just hope that the original person who wrote the code is still there to help you fix it. So we're of the mindset, if that your code is your end product, then you should probably be using Kedro. And this is what some of our client data scientists have said. And we kind of stick to this, this mindset. So what is Kedro? If we go back to that previous example where we were looking at those two buildings, so one was kind of like a building that was cobbled together with many different sheets, and the other one was kind of like a city skyscraper. Kedro is actually the scaffolding for your machine learning product. It's the scaffolding on that building. It's an open source Python framework that's maintained by Quantum Black. And it's a tool that focuses on rather how people will write data science code. The benefits are it's standardizing how machine learning is created. It promotes team level collaboration. It improves the overall structure and quality of your code, simplifies code handovers and maintenance, and makes it possible to build more complex data science and machine learning workflows, which is quite cool. If I introduce you to some of the concepts, I'm also going to try talk you through, I think, what would be alternatives in the R world for you to use, which could kind of replicate what you'd see in Kedro. So when we talk about the project template, cookie cutter data science is a tool that is used across different languages. So you will find that you can actually use the project template if you're acquainted with it. The project template that is in Kedro is actually derived from cookie cutter data science, and we've made some changes to it to account for, I think, feedback from over 170 client teams that have used Kedro in industry. We talk about configuration, and it's the process of removing hard-coded variables from machine learning code. So in that case, it looks at your data science parameters, maybe your train test ratio. You could iterate on that one, and that could be outside of your code base in one specific file. It also talks about how we remove file paths for loading and saving of data from your code base and actually put them into configuration so that it's separate from your code. Because if those things ever change, you shouldn't actually have to modify your code. You just modify the place where there's in configuration where they're stored. I'll show you what that looks like. We talk about our data catalog, which is what you can think of as a series of data connectors that allow you to load and save data from many different locations. And then we talk about our pipeline abstraction, which is essentially just functions that are linked together by specifying an input and an output. So if we go into more in depth with what this looks like, remember I mentioned the project template, super easy to understand. It's a series of files and folders that get generated every single time you do Kedro new. In the Kedro world, there's built-in support for logging, which is good to have if you want a reproducible workflow. We also support PyTest, which is used for creating unit tests for your code, and Sphinx for documentation. These are general best practice tools that you can use, but even cookie cutter data science supports some of these tools as well without you having to embed them yourself. What it means is if you learn this structure and you come and encounter another Kedro project, it's very easy for you to find where things are because you understand the structure, and you don't necessarily have to spend time sitting with someone and trying to understand what they did with their code base. Well, at least less time with them. We talk about configuration. Think of it as like kind of like settings for your machine learning code. And what it does is it keeps things like file paths for loading and saving data outside of your code base. It keeps parameters outside your code base. And it also keeps credentials if you're having to access maybe S3 or Azure and have certain credentials that you need to enter outside your code base too. We talk about our data catalog. As I mentioned, it's a series of data connectors for loading and saving your data. It just makes it really easy to never really have to write things like read_CSV would be the equivalent in Python. You'd never see a line of that code in Kedro because Kedro manages all those things behind the scenes for you. And you really just need to specify the type in Kedro, and Kedro will know which one it needs to be called. And then we speak about our pipeline abstraction, and I'll try and explain to you how it works. So we have a concept called a node, which is made up of an input data set being specified here, some sort of transformation or function in the middle, and then an output data set. And this is a node. A node is essentially a wrapper on a Python or a function that allows you to do this. When we talk about a pipeline, it's essentially a combination of many different nodes stitched together. But the cool thing is, Kedro will actually work out the running order for your pipeline. So you never really have to think of step one, I need to run this function, then I need to run this other function for me to get the end result. Kedro will work out the order based on what was specified as an input and what was specified as an output. And an example can be seen here. This output data set over here is actually this input data set here. And this output data set over here is actually this input data set here. And this is how Kedro resolves the running order for your pipeline. So yeah, it's a pipeline structure. I won't really go through how we think of like all these components fitting together. I guess maybe I could. So we've got a node. We mentioned it's the entry level function of a Kedro pipeline. Many of these nodes form a pipeline. To run a pipeline, you need something called a runner. This allows you to use either a sequential runner or a parallel runner, or even a thread runner if you're using Spark. And the runner will have to use the data catalog to actually load and save data for you using the different data sets that you've specified. And this is how essentially a Kedro run is done. We also do have a pipeline visualization tool that's built on top of Kedro that comes for free as soon as you write your code using the pipeline abstraction in Kedro. It is also a plugin that is available on our GitHub repository, and it's pretty easy for you to use. And there are different ways of deploying Kedro pipelines. I think this actually fits into the business model that is Quantum Black and McKinsey. We're in consulting. So whenever we go over to a client and they have different types of infrastructure, different ways of deploying those things, we need to be able to fit into that way of working, right? So this is why Kedro is very flexible in how it allows you to deploy in many different ways. But some of the things that it allows you to do is actually package your file as a Python egg or wheel, or use tools like Docker or Airflow to actually Docker for packaging your Kedro project in a container, and then you can choose to schedule that, or Airflow if you need to convert your Kedro pipeline into an Airflow DAG to take advantage of Airflow's ability for monitoring, scheduling, and orchestration. I guess maybe I can talk briefly about why we continue to use Kedro. And maybe I can also allude to why it's also written in Python as well. So consistent time to production. So now our teams can more accurately estimate how long it's going to take to work on a project, because we don't really have, I think, many disasters when we actually have to now convert what was supposed to be an insights report into a machine learning product. We also are getting benefits from code reusability as well. Because we write functions, we can actually now reuse those Python functions across many different other applications. It's also easier for everyone to work together on the same code base, because we now have like a standard of what software engineering best practice looks like for a pipeline. And then everyone is learning what software engineering looks like for data science code. Kedro kind of teaches you the hard way, no, I'm kidding, in an easy way, what some of those principles look like. So the question of why is it written in Python? The first version of Kedro was actually written in Scala. So it evolved out of a project where some of our machine learning engineers were really struggling to collaborate with each other. And the language of the time was Scala, so they decided to work with that. But we find that we switched over to Python because it kind of became a way for our data scientists and data engineers to meet each other in the middle. So our data engineers are typically involved with taking data from some sort of environment, and they do most of the data processing for the data scientists. So cleaning, feature engineering, and they used either SQL or Scala or sometimes PySpark. But back then, around the Scala days, PySpark wasn't really good to use, so they preferred Scala. But improvements in PySpark meant that more of the data engineers could pick up PySpark, so they did. But our data engineers used a combination of R and Python to actually do their workflows. So switching over to Python meant that our data engineers could meet the data scientists halfway, and we could start to have something where we didn't have multiple languages in one repository to hand over to clients or for teams to work on. It meant easier ways of collaborating with each other because you could now understand the code on either side. And then also in terms of what it meant as our deliverable for clients, we didn't need 2 people on the client side to read the code base. You just needed 1 person. So that's actually why we stuck with Python. But if you guys ever want to write a Redro, it's because you decided to make an R equivalent of Kedro, I'll be glad to hear that. I might use it. If you want to find us online, you'll find that we are up on Read the Docs in terms of documentation. We do have a few tutorials that you can walk yourself through. I think the longest one takes you about an hour to run through and gets you acquainted with intermediate functionality of Kedro. You can tag questions on Stack Overflow with Kedro and we'll find them. They get popped in our RSS feed, so we know immediately that something's been asked. And then we're up on GitHub. So if you check out quantumblacklab/Kedro, you'll find that you can raise feature requests, you can ask questions, you can file bug reports, and we'll be looking out for that during the week. And yeah, this is where I hand over to Tomas. And thank you so much.
Thank you. So now, after Yetu introduced you to Kedro and presented the general principles behind it, I would like to briefly discuss one of the recent projects where Kedro helped us a lot in advanced analytics. So let me start by a quick introduction to the project situation that we had, as it was quite complex. It is about a project for an insurance company. First of all, we had quite a complex and diverse data landscape. The data that we needed to process to build before building our models included both structured and unstructured data. For example, in unstructured data, we had some free text documents that we needed to OCR and extract relevant information. Furthermore, we needed not only client data, but we wanted to enhance it with external sources. And that required quite a complex operation of fuzzy matching of different data sets. The other complication was that we had just 4 weeks assigned to our modeling phase. And during this time, we needed to work on 4 major use case families. Think of them as groups of use cases. So for each of them, we needed to design and build at least 1 machine learning model, but usually more than 1. And each of these models had its own specificities and differences, such as different types of modeling, different target variables, or different granularity of data that we need to use. During this modeling phase, there were a few objectives that we wanted to achieve. First, we wanted to build prototypes of machine learning models to understand if we have enough signal in the data to proceed with each of the use case. But this wasn't as simple as that, because it was equally important for us to estimate value at stake. So in other words, to assess what is the impact of potential interventions on the targets of each use case. We did this by performing a counterfactual scenario analysis on each of the models. And finally, there was an additional requirement from our client that the models needed to be explanatory. So features needed to be human interpretable. We had to be able to assess feature importance and also the directionality of effect of each feature on the target variables of our models. It served 2 purposes. First, which is obvious, it simplified the quality checks on our models because we could understand the impact of each feature. But secondly, our client wanted to understand the key factors that influence the targets that we wanted to explain. Last thing I would like to mention about this project was our team. We worked in a very large team. Of course, the exact team composition changed from one phase of the project to another, but typically it involved more than or about 10 data professionals, so data scientists and data engineers. Of course, on top of it, we also had business consultants. And of course, it's great to have such a large team, especially when you work on a complex matter like this. But it's, on the other hand, also much easier to get more chaotic and lose the track of what you are doing, lose the structure of the whole code base. And now that moves us smoothly to Kedro and how it helped on that project. I would say that using Kedro helped us in 3 different ways. Those are structure, efficiency, and consistency. Let's start by the structure. One of the greatest things, in my opinion, in Kedro is what Yetu already mentioned in her presentation. So the fact that it imposes dividing a project into pipelines composed of separate nodes. And by this, we don't mean just a modeling pipeline such as scikit-learn pipelines or some, let's say, carrot pipelines in R, but there is much more to it. When you work in Kedro, you naturally start building end-to-end pipelines. Pipelines that start with data ingestion through data processing, through modeling activities, up to some post-modeling analysis, such as what I mentioned before, so model explainers or additional scenario analysis. And building such a pipeline or such pipelines was exactly what we did on this project. The whole effort was built as Kedro pipelines. And that made the cooperation in such a large team very easily manageable. Everyone could work on their own nodes, and the integration between the nodes was very smooth. I would like to highlight once again what Yetu said about the running of Kedro pipelines and managing dependencies. So the good thing is that in Kedro, you don't need to pay much attention to dependencies between nodes. When you run a Kedro project, you don't need to run the project in its entirety, but what we happened to use very frequently was to run just a part of project. For instance, when you receive a new version of the data set, or when there is a new way of calculating some features and you want to refresh the output of this calculation, you can point Kedro just to the node that you want to run, and it solves all the dependencies for you. And it is very important in situations where many people work on the same code base, the situation that we observed on our project, because sometimes you just don't know all the dependencies that are in the code. So such a tool makes life much easier. What's also important about pipelines from practical point of view is the fact that such a clear separation of the modules into separate nodes allows to minimize Git conflicts, as everyone could have worked on their own files. So for most of the time, we didn't have any issues with Git conflicts on our project, which was also very helpful. And speaking about structure, there is also a second flavor to structuring the project apart from pipelines and nodes. This is about structuring all the data in separate layers. On our project, we use different layers such as raw, intermediate, primary, feature layer, and so on. You can check some recommendations about different layers that you can use on the website kedro-readthedocs.com. And such a structure made it easier for us to run quality checks on our data. So for instance, we observed some weird issues in the data, like unexpected values of some features. And thanks to having this structure and separate layers of the data, we were able to easily trace the problem, to verify in which layer it happened for the first time. So whether it is about the source data or whether it's about some processing step of the data. That also helped a lot. Now, after structure, I would like to highlight the benefits to efficiency that we got thanks to Kedro. So as I mentioned, we had multiple use cases on this project. And of course, each of these use cases was different. Each of them had its intrinsic properties, different target variables, different source data, and so on. But on the other hand, there were some elements, the meta structure of the use case that was shared between all of them. So for instance, we decided that for explainability, we will use a method based on Shapley values. And we delegated this part of modeling to a separate Kedro node. We defined our requirements for explainability that were shared among all the use cases, and we made one person responsible for developing a node that could be shared among all of us. In general, Kedro makes such abstractions of common processing logic to separate nodes very easy. So in the end, we ended up with some nodes that could be reused in different places on the project. And this naturally leads us to the third part, that is consistency. So by consistency in this context, I mean the consistency of the main outputs of our models. So of course, each of the models had different internals, but for the main outputs, we managed to reuse the same code and produce consistent layout of the outputs. And I think that helped our client very much to focus on the content instead of trying to understand the structure of each output for each model separately. So by having this consistency made easier by Kedro, we also made the business meetings and explaining the outputs of our models much easier. So to sum up, I believe that leveraging Kedro helped us a lot to deliver this project in such a short time frame. And I think that because of it, we could focus on value-adding modeling activities and carrying out different modeling experiments instead of struggling with chaos and trying to fix the basics. So I would highly recommend Kedro on your analytical projects. Thank you.
Okay. Thank you, Tomasz. Thank you, Yetunde. Thank you all for joining today. I can tell that Kedro is really interesting product, and I'm really happy it's on GitHub, and there's a Stack Overflow thread for it. So thank you for deploying and sharing such a tool. I think we can call it a day, and thank you for joining. And I hope that people on the audience on YouTube enjoyed. And don't forget that tomorrow we have another session by McKinsey. It starts at 1 p.m. UTC +2. So that should be 11 UTC, and we will have another talk. And if you have any more questions and would like to follow up, please join that call where we have some more time for Q&A. And remember, there's also an evening booth tomorrow by McKinsey at 5:30 UTC +2. So thank you for joining, and have a great night.